This
inspired to have
conference will
with
now
us
be recorded.
our second presenter is another great personality, Mr. Nilesh Agrawal, training head and instructor at Decodify Education, graduated from Indian Institute of Information Technology, Guwahati, software developer at R&D Wing, Samsung. He is specialized in machine learning and data analytics. So, without wasting the time of our participants, I would request Mr. Prithvi Shen sir to kindly enlighten the participants. Prithvi sir, can you please start? You're most welcome.
So, good evening, brothers and sisters of JC. Uh, so today, as you all know that myself, Prithvi Shen, I was the ex-student of JC. So today I am going to present and talk on career opportunities in artificial intelligence. So at first, I would like to put some light on the meaning of artificial intelligence. I mean, informally. So in computer science, artificial intelligence is sometimes referred as machine intelligence. It can also be said that intelligence of the dumb machine, in contrast to human intelligence. So moving ahead, we have goals of AI. Rather, I can interpret it as traditional problems of artificial intelligence, which includes reasoning, knowledge representation, natural language processing. Then we have perception, and etc. So the formal definition of AI, put forwarded by famous data scientist, Mr. Dr. Andrew Ng, as he says that the rise of AI has been fully driven by only one tool called machine learning. So the most commonly used type of machine learning, as everyone knows, might it might be like you might not know, but maximum CAC people might know this. It's supervised learning. So here we do something as input to output mapping. There will be some input and the corresponding output will be generated, and that is known as input to output mapping. So moving ahead, let's see some examples. Let's say we have the input is email, and our AI application's job is to filter out those emails on the basis of whether it is spam or not. Then the corresponding application is known as spam filtering. Fine. So let's see. So these are some messages which contains spam and normal messages all together. When it is fed into the classifier classifies into two types of classes. One is known as inbox or normal messages, and another is our spam messages. Fine. So our artificial intelligence does that, does classifies or does separates the two classes based on the their filtering methods that we are going to use. So next example is if our input is audio and our AI's job is to text transcript those audio inputs, then our corresponding application is like speech recognition that you see in this Google Home or Alexa. All those things are like they are doing speech recognition using natural language processing. Fine. So moving ahead, we have if our input is image radar and all those radar information we have, and the corresponding AI's job is to find the position of other cars, then it is the application is self-driving car. Now let's see some examples of civil engineering too. So in civil engineering, let's say we have at the construction side, we have thousands of quality issues. So no human being could or would want to read them every single day. Instead of hiring a team of people going and looking for those issues and also categorizing those issues, then rather than we can also have a machine learning model that looks at the data and gives some meaningful representation or information out of out of what we have in hand in seconds. So let's say like expanding this like scenario to a like next level, we can see, let's say we are using a long checklist of those like issues, and instead you if we don't want to use this checklist, we can use make use of just click a photo of those issues, and that picture can be used to fill the checklist and find out those issues. So one more is like we have this say price of material can also be determined, and for with that we can see like if the price can be decreased, and what is the like predicted price of the whole material or at the construction site. So you can imagine it like we have a machine that predicts the price of the materials that you are going to bear. Now we have like say safety issues can be also monitored using sensor data that that a machine can predict whether the sensor data that we are having can a person is in danger or not, that can be predicted using our sensor data. Fine. So in mechanical engineering, let's say AI in manufacturing industry, we have a model this say this the video is of like BMW industry at Germany. So like this model, the AI model is designed to detect cracks in the model, and also to see whether the attached these designations in the car are attached correctly or not. Fine. So let's play it. Just like the image classifier, like email classifier, it also classifies those parts having like they have whether they have defects or not. Fine. So they will classify accordingly, and they will just discard those parts that does have defects like manufacturing defects in that. Okay. So this is one such example. Another example is in like a power generation like industry. Say for example, say I am taking the example of Guwahati. Guwahati requires 60 megawatt of current to like satisfy the demand during peak hours. Say your thermal power plant doesn't generate that much of like a power. Say it generates 45 megawatt of power, and you want to satisfy uh, all the clients during its peak load, like it needs more than 60 like a megawatt of current. So what it will do, AI will determine the time during which the peak load occurs by looking at the past the data that it has seen. Our machine will look into the data previous datas, and those are labeled as peak load or not peak load, and it will say whether like more power is required at that period of time or not. Fine. So this is one such example in like electrical or like electronics industry, like power generation industry. Now let's move to our previous topic, what is the definition of AI and how like it is better than traditional machine learning algorithm. So like now supervised learning, as we have seen, supervised learning has been around for many decades, and it has really taken off in the last few years. Now let's see why is it like that. Let's compare it with some a graph like performance versus amount of data. So the amount of data that we have now had really grown over the past few decades. So we should thank to the rise of internet and rise of computers actually. So you can consider this amount of data axis can be of speech recognition. Let's say we are using application is speech recognition application. So we have amount of data is input data is audio, and our task transcript is our output. So it has been seen that with with the increase in the amount of data, the performance is not that well using those traditional AI, like using traditional supervised learning or we have different type of machine learning algorithms. Using those algorithms, it has been seen that it is not that accurate. Fine. So and using our modern AI, using neural networks and deep learning, it has been seen that with a very less amount of data, the performance increases. It shows accuracy to a greater extent. Fine. So so from here you can infer that like AI has really taken off recently because of the rise of deep learning and neural network. So that's why we call it like our new era, or a new like this like systems are made of modern neural networks or modern AI. So AI is nothing but implementation of neural networks, supervised learning, unsupervised learning, reinforcement learning, all those three, all those algorithms we have, or all those problem statement we have, we combine everything and make it make our known like a well-known modern AI. Fine. So let's see what AI can do and cannot do. Let's say you are building a self-driving car, and here's something that AI can do pretty well is just take a picture of what is in front of your car, and maybe just using a camera or maybe using some other senses as well. So example, we have radar or lidar, and then we can figure out what is the position of other cars, or where are the other cars. And so this would be the AI where input A, or we have our input to output mapping. So where input A is the picture of what is in front of it, and or maybe output of some like a radar or some lidar or other sensors, and output B is the position of other cars. And today's self-driving car industry has collected enough data and has pretty good algorithms. So they are doing reasonably well. So that's what AI can do today. Fine. So moving ahead, we have what AI cannot do. Like this would be very difficult using today's AI, in which we have certain images like this. Say whatever we and human is trying to gesture at your car, or what is the if we see an image, and if we want to try to output the we try to output the intuition behind the what that person is making gesture at your car. So here is a construction worker holding on the hand, asking the cars to stop, or someone over there trying to wave a car to stop, or a bicyclist raising her left hand to indicate that she want to turn left. And so if you were to build a system to learn A to B mapping or input to output mapping, where the input A is a short video about human gesturing at your car, and the output B is what's the intuition or what's the intention, uh, like uh, 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 the person has, or what does the person want, is a difficult part to do. Fine. So the problem is that the number of ways people gesture at you is very, very large, and so it is very difficult to collect enough data from millions of people gesturing at you. So another such example we have, say, X-ray diagnosis. So what AI can do? AI can diagnose pneumonia from 10,000 leveled X-ray chest X-ray plates or X-ray images we have. And what AI cannot do, we have it cannot diagnose pneumonia from 10 images from a medical textbook explaining pneumonia. Fine. So here also we have A to B input to output mapping, where A is nothing but the leveled images, and B is the output, what is whether the person is having pneumonia or not. So here are some strengths and weaknesses of machine learning. So machine learning tends to work well when you are trying to learn a simple concept, such that something that you could do less than a second of mental thought. And when there is lot of data available with you, then our machine learning, this traditional machine learning, will work well. But the machine learning tend to work poorly when you are trying to learn a complex concept from a small amount of data. Fine. And second underappreciated weaknesses of AI is that it tends to uh, do poorly when the machines performs on the new type of data that's very different from the data that it has seen in your data set. So let me explain with an example. Say we are building a supervised learning system such that it uses A to B input to output mapping to learn to diagnose pneumonia from images like this. We have on the left hand side, we have good quality images. On the left hand side, we have certain images that are aligned to say 45 degree or 75 degree, some angle, and the images does have some scripts. So as you can see on the left hand side, there are some pretty high quality chest x-rays. So you are building your system with those chest x-rays that are pretty high quality. Fine. So let's say we apply this AI system at different hospital or a different medical college or medical center, where maybe the x-ray technician somehow changed the patient's orientation, and sometimes it might be there might be defects or like scratches in the image that you can see in the right hand side. The performance might be quite poor. From this we can say that today's AI is much weaker than human. Let's see this, what does this deep learning and neural network mean. So the term deep learning and neural network are almost used interchangeably in artificial intelligence. And even though they are like great for machine learning, but there are hype and mystique about them. So let's demystify with an example. Let's say we have a like a demand prediction. Let's say you are building a website that sells t-shirt. Fine. So we want to know based on how we price the t-shirt and how many units we are going to expect that like it is going to be sold. Fine. So we might create a data set like this, where the higher the price of t-shirt, lower the demand. Fine. So we can put a straight line like this, such that the price goes up, the demand goes down. Fine. So demand will never go beyond zero. So this blue line will flatten to zero like this. So this line, this blue line, may be specified as a simple, simplest possible neural network like this. So where A is the price and we need our demand, so we can put a circle in between this A and B as like this, and this circle is nothing but the neuron. What it does, it computes the blue line that is drawn over there. Fine. So let's take a complex example. We have, let's say, price, shipping cost, marketing, and material, all those things we need for to determine the demand of a say t-shirt. Also like doing marketing, you are making aware uh, your customers will be aware of the new collections that you have at your store, and also like the materials that you are going to use also will have an impact on the demand. Fine. And also the like affordability of the consumer will depend on the shipping cost and price. So let's say price and shipping cost determines the affordability. So let's say price and shipping cost can be put into a neuron, and which determines the affordability. And then we have, let's say, price, marketing, and like material. Before that, let's say marketing gives us some awareness, it creates some awareness among the people that new collection has arrived, you can buy it from the store or from our outlet. And also now price, marketing, and material, all these three can be also our material is also an important issue. So we can determine the perceived quality of our product. So price, marketing, and material, all these three together can be used as to determine the perceived quality of our material. So all these three, affordability, awareness, and perceived quality, all these three, if we input into a neuron, and it can give us the demand. So it is nothing but multi-layered neural network. Fine. So here also you can see A to B input to output mapping is done. Fine. So we are just creating awareness of what we have right now, what is AI and how this this all these things goes on. Like in a class of in a webinar of 1 hour, I can't show you the coding or go into the depth of all those things. So forgive me for that. So let's go ahead and see. Let's see the deep learning aspect of AI. Let's say we have a face recognition application. Let's consider a part of the image, in human eye. From our human eye, we can perceive the whole image as something that the person, we can recognize the person, right, by looking at them. But if we have a image and if we give it to computer, it will recognize in terms of some numbers. Fine. The computer sees a grid of pixel values or pixel brightness that tells it for each of the pixels in the image, how bright is the image. Fine. So if it were a black and white or a grayscale image, we have only single value. So image then like each pixel would correspond to a single number as I said, that if it were like a black and white image, like, or a grayscale image, it will have the pixel values will be a single number. So that will tell you how bright is the image or how bright is that pixel. So if it is a colored image, then each pixel would actually have three numbers corresponding to the value how bright are the red, green, and blue elements of a, like a uh, of that pixel is. So the neural network's job is to like input lot of this a lot of these numbers like this into the into this channel, and tell you the name of the person in the picture at the output. Fine. So the last example, in the last example, we have seen that the neural network takes four numbers corresponding to the price, shipping cost, material, and marketing amount, and outputs the demand. Here, the neural network has to input a lot more than the numbers that we have seen before. That corresponds to like all of the pixel brightness values of the picture. Let's say we have in this image is of resolution 1000 by 1000, as we have you know what resolution is. So if you multiply this 1000 and 1000, we have 1 million pixels in total. And if it is a grayscale image, then only, and or black and white image, then only, or if it is say a colored image, then it will have 3 millions of these pixels, because we have three channels: red, green, and blue. Fine. Now neural network will try to detect the parts of the object. In the first phase, let's say the parts are detected as edges, like eyebrows, eyes. We have edges everywhere. Edges are differentiated by strong change in the pixel intensities, from black to white or white to black, whatever we have. So in the second part, you can imagine it this neuron will determine let me draw it. These neurons will determine the shape of the eyes, nose, whatever we have features at our face, that will be determined by this part of this neuron or this network. Fine. Now we have at our last before the last phase, we have our these neurons will determine the face, the person's face, and at the last step the person will be identified. Fine. So it is not our concern that what is going on inside. We need to just feed the values and we will get the output. Fine. So this is the beauty of the neural network, that if we feed some value and at the end we are getting some output. Fine. So although we need to know some like a basic operations, how these are done, that can be learned in different ways. So let's see some trending topics and then we will discuss some projects regarding that. Um, let's say extra hardware is for computing those complex mathematical operations in our computer. We might end up needing an extra hardware to perform those complex mathematical operations. So AI enabled chips will make sure that those tasks requiring more number of computations, such as face recognition, natural language processing, all those requires high number of mathematical computation. And if you are good at mathematics, I think you will be the masters. You will be masters in this basically linear algebra containing vectors and all those machine learning and AI. You will be masters in that. Fine. And also you need to know this probability theory. So AI enabled chips will make sure that. Fine. So what chips we have? We have chips from NVIDIA, Qualcomm, then AMD, etc. So next is we know that there are billions of IoT devices in the world, and each device, or you can say that IoT devices creates lot of data that is every instant of time in terms of some petabytes. So like these those data are to be like mined or processed to take out some meaningful information from that. So here you can see an example of weather forecasting device that processes data in real time. Next is our automated machine learning. As discussed earlier, traditional machine learning performs poor over the huge data set. So AI's role is to enhance those performance. Next is we have like artificial intelligence in and cloud computing. Examples we have Amazon Web Service. I think many of you have used this. Google Cloud, IBM, Oracle, then Alibaba, etc., etc. We have Adafruit also. So here AI can be used to manage and monitor issues in the cloud, and some experts also predict that AI can be used to automate the basic workflow of those both private and public cloud computing systems. Now, AI in cybersecurity. The addition of AI to cybersecurity can improve the analysis, understanding, and prevention of cyber crimes. So let's see what self-driving car industry has. So we will see a code where we can determine these lanes. Yeah, you can see over here, these are the lanes that are to be determined for the self-driving car to like drive the car into a perfect line or perfect alignment. Fine. So this can be done using two methods. One is using leader or lidar, or another is we have our computer vision algorithms. Computer vision is nothing but using image processing. So let's see this.
Than a Tesla Model 3.
So this is a lidar.
A lidar is a laser
that is like basically used in self-driving car industry.
The whole 360 degrees up to 20 times a second with 32 layers. The data is transferred via UDP. Lidars are quite
So
popular.
you can see the data.
Because you get the distance right away. But there are also vision-based systems like on the Tesla Model 3, which have to calculate the distance by analyzing stereoscopic images and tracking image features. Elon Musk just stated at the Tesla annual shareholder meeting his belief that vision-based systems are.
So we will see the vision-based system because we don't have lidar right now. Let's see this video. So what they do is they have like used this 8, or this 8 can be used. Yeah, I think many of you have given like a driving test. So you have to drive your car in this 8, right? So basically this 8 is fixed onto a certain map, and the car will move onto this 8 only on the bounding box, or like you can see that uh, car will be tracking this path only.
This 8-loop path in the visual map. This visual map of its features is matched to the environment scanned by the card. Outdoors, this will be obviously assisted by the GPS. Now the card is engaged with the target path within the hangar and will try to follow it. That's actually enough to let it drive a track without a driver. Since we cannot let it escape to evolve to Skynet, a volunteer driver controls just the speed at which it follows the path. We outline the track it's going with these cones. It's amazing how repeatable it is, even if we set the cones really narrow to the card. And this is probably not achievable by regular human drivers anymore. Of course, there are limitations. This
So let's see a vision-based problem. So this is an like you can say sort of hands-on, not that like I am not going to code, like I'm going to just make you understand how this works. In self-driving car industry, basically finding links using computer vision like based like a tool, you can, the step one is to like convert the whole this colored image into grayscale image. Then also obviously we need to reduce the noise, like we can use some filters like a Gaussian filter in image processing. After that, we are in the system, we need to determine like what is our like this lines or these pavements we have. So we need to determine like the edges in the image. So all those edges will be determined, like let's say this is an edge, this is an edge, this is an edge, this is an edge. All those edges will be determined. And now we need to, in our step 4, we need to find like the region of interest. So which region do we need? So we will mask everything like this. We need this lane, so we will mask everything as like we will deduct or will subtract every values out of like this region, and we will say that like this is our lane or this is our path. Fine. So this can be done using our like algorithm that I have coded. Let me show you here. So you can see we are going to form a triangle like and also we are going to mask like using some bitwise end like with zeros. So whatever the values we have at our region of interest will only be displayed, and rest of the values will be like deleted. Fine. So and then I have like tested for a single image, and then I have tried for a sequence of like image, or you can say like video frame. Fine. So like this is one of such example. I can show you the like running example of this model. Let me show you. So this is the running example we have. All it does, it detects the edges of our like region of interest, basically the lanes, and it enables us to drive our car onto the lane. Fine. Another such example we have, let's say image style transfer, where we do, as all of you might have used this photo lab. So where we use two photos or two pictures, either the picture might be an like a might be you, and the style, corresponding style. Fine. So we style the image accordingly. So we have like this representation, we have certain, say like an image that is basically the building, and we have our input style. So we feed into our network or neural network, you can say a convolutional neural network. So where the styles are represented like that. Fine. So and at the end of the like network, we can see that our styled image has been formed. So this is nothing but we try to fuse these two images having like a namely styled image and our input image together into a single one. So basically we need to train our before we style our image, we need to train to get our predicted style. So that's why if we input new images, like we have our style image and our like like input image, if we have, then the machine should be able to recognize that okay, we have styled image and input image, we need to combine both of them together to form a new image known as like styled image. Fine. So let's see like using our image like TensorFlow. So I have basically imported some functionalities of TensorFlow over here, and then basically starting from the like from the bottom we have two contents images. We have downloaded the image over here, and then we need to load those image into our like path. So we have loaded the image, and then we have displayed the image over here. Now we are trying to load this model. You can use TensorFlow, or you can use any such model that TensorFlow does have. Like for this scenario I am using pre-trained model, because if I show you the trained model, it will be like a tedious uh, so it will be time consuming. So that's why I have chosen to use like this model or architecture as arbitrary image stylization v1 256 is the name of the architecture. Like convolutional neural network, in convolutional neural network we have certain things like a Lenet model, where we have like basically max pooling and then convolution and layers, all those things we have. If you study this image processing, you can figure out all those things. As I am not going to discuss all those things, because those are huge like domain, and it will take more than say 5 to 6 hours of like a continuous class. Then you will get like know all those things. So here what we do, we try to blend both these two images together using our we have our model. So what we do, we pass these two images into our model as this tf.constant style image and content image. Whatever the image we have, both the image will be passed, and it will be then passed to tensor to image function that we have above, here. So what it does, it will convert the TensorFlow this image or tensor image to a numpy image, and which can be shown numpy is nothing but numerical Python that is used for complex representation of like mathematical arrays or like that. Fine. So what it does, it basically fuses both these two images together, or blend both these images together to form a new image known as styled image. Fine. So like with this I have shown you the basic workflow of how this happens. Now let me show you a project that I did during my BTech from Jorhat Engineering College. It might inspire you. So I have used a image recognition algorithm. Along with that, I have used natural language processing. Let me first forward. So whenever the machine sees me, it prompts hello Prithvi, how are you, or like that stuff. Fine.
Hey, Prithvi, I'm Lucy, your personal assistant. So how can I help you?
Lucy,
Yes, dear, I'm here for you.
Lucy, how are you? What is the date today?
Today is Thursday, 14 June.
What is the time right now?
It can order pizza, it can turn on the lights, it can do anything. It can see the weather forecast, it can search in Google, it can like this was made by me like self scripted. Whenever when I try to make it commercial, like with Anvaya, you know that Anvaya so at that time, at that period of time, I got to know that Amazon and Google have officially launched this sort of application, or this sort of device as Google Home and Alexa, you know that. Fine. So
The time is 10:11 p.m.
See,
so as I said, it can control electrical appliances.
Yes, sir. Turning off the AC.
turn off the light.
Yes, and turning off the light.
It is built upon this Raspberry Pi, and I have made my own hardware devices like relay circuits and all those devices.
Who created you?
I was made by a team of computer science and engineering at Jorhat Engineering College.
At that time, this was the best project of all the branches, so we got appreciation from everyone.
Lucy.
Interpreted high-level programming language for in the Indian city of Agra.
So it can search in Wikipedia, as I said before.
Search for Python programming language.
According to Wikipedia, Python is an interpreted high-level programming language for general-purpose programming.
Play in YouTube Raghav Chaitanya songs.
So it can play in YouTube, it can play in Savan and all those things.
Sure. Why did the banker switch?
What is the weather in Shillong?
So it can forecast the weather also.
The weather in Shillong is mist.
So I'm not gonna show you the whole project. You can see in YouTube also. Because we are going out of time. So this is a simple project that you can refer to. If you have motivation of doing projects, of doing making new innovations, you can do that. As Jim Collins said, that good is the enemy of great. Fine. So we don't have good infrastructure because we don't have great infrastructure because we are good with those, we are okay with those good infrastructures. Fine. You need to change your mindset to become the best engineers. You all are good, because I passed out from JEC and I know that we have that potential. We can show something different to the world. As Professor Malay said that he's a well renowned renounced professor. He said that I didn't find any people from JEC coming to Triple IT institute, that the Triple IT institute is very good, that those students are very good in their academics and all, in every field, in coding field, on every field. So he was shocked seeing a JEC from a student from JEC can be that much good. Fine. So it's not an issue. You can learn, you can try, start from learning from today. If you need help, we are there to help you. Fine. So now this Mr. Nilesh from Samsung will basically take from here. He will show you some of the aspects of this, what are those competitive coding and how to prepare for interviews and how to get recommended in industry and in Amazon, or how to get into Amazon or like that stuff. Fine. So Nilesh, are you able to hear me, Mr. Nilesh?
Yes, yes.
Yeah, Mr. Nilesh, you can start.
Okay. So good evening, everyone. Basically, first me give you a brief introduction about myself. My name is Nilesh Agarwal, and I study engineering at IIT Guwahati. And currently, I'm a software engineer at Samsung.
Mr. Nilesh, you are not audible. Uh, you are not audible. I mean, I think your network
Everyone
is having
Samsung
some issues.
research and development. Every one of you must have a dream at Delhi. So basically, like into the top techs, like everyone must have a dream to get into such as Facebook, Amazon, Google, be it private sector or even government sector also, or all the
Mr. Nilesh, you are not audible. No.
Am I audible now?
Yeah, you are audible now.
Hello?
You are not audible. Please,
Hello? Am I audible now?
yeah, you are audible. You can speak it.
Okay, okay. So shall I continue?
Yeah, continue.
Yeah, so what I was saying that I did my BTech from IIIT Guwahati, and currently I'm a software engineer at Samsung, research and development wing at Delhi. So like every one of you must have a dream to get into the top tech such as Facebook, Amazon, Google, like be it private sector or even government sector such as IOCL or the Maharatnas which are there. So like everyone you have a dream, but you do not know the secret how we can get into such tech companies. So like today I'll be talking about competitive coding and how it will help to get into such companies. So every company like be service based such as TCS, Infosys, or like product based like Amazon, Google, the interview rounds are basically coding rounds. So here competitive coding will help you take a lead. So first, before starting into how to start competitive coding, let me talk you about the interview process of a few companies. So companies such as Amazon. So Amazon usually pays around 20 to 40 lakhs per annum. So that's a huge amount of money. So the trick to get it Amazon is that they usually conduct 6 rounds of interview. The first round is online coding round. So there they will give you an assessment where they will ask you two coding questions and 28 MCQs based on data structures and algorithms. So there you need to crack both the coding questions and if given in a stipulated time frame. So you'll be getting only 45 minutes to crack those two coding questions. After that, if you clear the coding round, you will be invited for an on-site round. So in on-site rounds, you will have 4 rounds, each of 45 minutes. So each of the 45 minutes on-site round, you will be asked questions based on data structures and algorithms, such as you must be knowing linked list, arrays, tag, queues. So there will be questions based on these data structures, and you will be given 45 minutes of time to code at least two questions based on data structures and algorithms. And after that, finally, you have a leadership principle round where they will ask you questions on the leadership principles of the approached company. So this is the interview process of Amazon. So if you think that Amazon usually do not visit your campus and how you can apply, so the means you can easily get a referral from the employees of Amazon, or you can also apply in their career website. So LinkedIn here plays a very vital role. You can approach people who are already working in Amazon, and they will usually give your resume to the recruiters, and they can contact you for the interview process. So don't think that the company doesn't visit your campus, you cannot get into this top tech giants. And similarly, like Samsung usually pays around 20 lakhs per annum. So what they will do is that they will conduct an online round. So basically, they will give you 3 hours of time, and you have to solve a coding question. So the coding question will be based on dynamic programming or the common data structures. After that, if you clear that round, you will be invited to two on-site rounds. So this will also be based on data structures and algorithms, and then with one HR round. So even these big companies and or even the small service-based companies like TCS, Infosys, they also conduct, like TCS recently conducted TCS Code Vita where they paid from 7 to 20 lakhs per annum. So there also the initial rounds are coding based rounds only. So you have to be good at competitive coding so that you can clear these rounds. So I'll tell you a basic roadmap of how you can excel at competitive coding. So basically at first you need to know the basics of any programming language. So be it be C, C++ or Java, you need to know all the basics such as loops and the conditional statements or the object-oriented programming concepts such as polymorphism, inheritance. You need to have a basic idea of all the programming language. So after you have a basic idea of these languages, you need to know the standard template libraries such as if you are given a question where you need to sort an array, you don't need to write the whole sorting algorithm or the you can easily write sort array comma array plus n and it will automatically sort your array. So this one liners, this can help you a lot in the coding contest. So or the coding interviews, you can easily instead of taking hours to crack it, so they crack questions in minutes. So this will means basically help you a lot. So after covering all the very lot of libraries such as hash set vectors, so they help a lot. After that you need to know all the basic time complexities and logic complexities. So what will happen is that the interview will not only ask you a question. So after asking a question they will say that okay, solve this question in order of n or order of n log n. So you need to solve it at the best possible time complexity. So knowing about time complexity and space complexity will help you in the cracking the coding interviews. Not they will not help you much in the coding contest, but they will help you in the interviews. Then basically you'll have knowledge of all the algorithms, but you need a mentality, a concentration of how you can approach this in a real interviews. For that you need to participate in contests such as code chef, code forces. So this contest will give you a feel of the real interviews that occurs in the real scenario of top tech companies. So there they have questions in the real questions which will be very likely be asked on the interviews. So after you participate in such contests, there are the order is first you need to practice the linear search. You need to practice all the common numbers such as palindrome numbers, perfect numbers, Armstrong numbers. So these questions are directly asked in interviews such as TCS Wipro. Then you need to cover hashing, prefix sum, and all the basic techniques such as sliding window technique, two pointer techniques. So these techniques help you a lot in the interviews. And binary search. Binary search is the most important algorithm when it comes to on-site interviews. So this is the order that you need to follow in order to excel at competitive coding. The list goes on, and I can give you a detailed list of all the algorithms and all the data structure that you need to master. Then after you complete all the basic algorithms of competitive coding, then you need to have a mastery over of all the data structures. By data structures, I mean that linked list, stack, queues, trees, heap. So you need to know all these data structures because the interview will, if the interview asks you a question and you do not know the answer, the interview generally gives you a hint. Okay, you can solve this question by the use of trees. So if you solve this question with the use of trees, and you do not know how to code it using trees, then the interview will do not select you. So this can be a major drawback. So you need to master all the common data structures. Not only master, you need to have at least a basic understanding of all the sorting algorithms or the searching algorithms. Like the interviewer can directly ask you what is merge sort or can you code quick sort. So there you need to give the code, the production ready code directly. So this is why you need to master all the data structures. So like what we do at Decodify is that even if you don't know the basics of any programming language, like for the initial years, if you're from first year, second year, if you do not know all the basics of any programming language, we'll start off with the basics of a programming language. Then we'll give you a slight idea of what is competitive coding and introduce you to all the common platforms such as CodeChef, Codeforces, and give you assignments based on these platforms. After that, we'll take it into each of the data structures and we'll teach each and every data structure from the basics to the depth. So we will make you at least interview ready for the upcoming interviews so that you excel at the interviews and do not get stuck at the basic things. So this was all from my side. And if you have any questions regarding the competitive coding, data structures, or regarding AI, you can ask us now.
So one basic question I would like to put forward to you, like many of you might not know, what is the difference between AI and machine learning? Can you answer? Like, please turn on your mic and could you please say anything that you know? Just please try to interact. Like, see, I am your alumni. Just like treat me as a brother, not as a like uh, someone from outside. So I am your alumni, and you are my like brothers and sisters, like attending the meeting. So can you please ask, like answer the whatever I asked? Anyone? Okay. The basic difference is that suppose if you are using a wash basin, like in wash basin you have like that is automated basically. So that is also an AI. Like when you put your hands like in front of your like a tap, the water flows down. Fine, that is AI. That doesn't have any like machine learning concept over there, but it can be said that it is an AI. Fine. And one such more example that AI can also be implemented using machine learning and deep neural networks. But also, it is true that all IoT devices, all embedded system devices are artificial intelligence devices. Fine. Or application of artificial intelligence. So, any more queries? Please ask. Any queries? Please ask. No more queries? So for more information, you can contact us. We have Decodify. Basically, we are like we would be happy if we could help you to progress in your life. Fine. So with this, we would like to end our meeting, and the this feedback form will be posted onto your Gmail. We'll mail you the feedback form. Just fill up the feedback form, and also those who have attended the meeting, basically they will be provided certificate of participation. And also any queries related to like education in the field of AI, machine learning, or whatever you have in the field of this competitive programming to get into this top MNCs, you can contact us. We would feel happy to help you. Fine. So with this, I'm ending the meeting, and we will send you the this uh, feedback form within a few within half an hour. Fine. Thank you. And you asked some question: is AI concept based on lots of data? See, the everything you have in your hand, right at your hand, generates lot and lot of data. If you see your smartphone, it generates lots and lots of data. So you can consider that AI is a concept based on like data mining or data inferencing or data like prediction. Whatever we have at our hand, we are just playing with our data. So it is also based on like lots of data that we have. So the concept is like we need to make predictions before something happens. So you have read probability theory, right? So just like probability theory, we are just trying to infer in real time. Fine. Any more questions? Can we develop a sixth sense technology using AI? Like, uh, yeah, basically, whatever you asked, you are asking about this Pranav Mistry, right? So my device, like my device, it is possible. It is possible. We are working on that device. Basically, I am doing my research in the field of OCR, so optical character recognition, and like in the field of computer vision. So basically, those are the devices that are made by Pranav Mistry, the 6N technology. Basically, it is complete like fusion of like we have this computer science and electronics together, right? So my BTech project was also like that. Fine. So which consists of this image processing, as well as it was a combination of this natural language processing and embedded systems, right? Also we have IoT impacts on that in that machine also. So we can develop using AI. It is possible. AI is nothing but the application part. Inside the AI we have different types of algorithms, like we have machine learning aspects, deep learning aspects, then we have embedded systems aspects, IoT aspects, everything combined together to form this AI like in like real time. Fine. Or you can say the application is AI. Any more questions? Please feel free to ask. You can turn on your like mic and ask. I would feel happy if you interact. Okay. So no more queries. Fine. So thank you everyone. So I am closing the session. Thank you.